Hello friends, good day to all. Today, let us know what is new mode of power generation in vehicles. In coming years, cars, scooter, motorcycle or small vehicle, which uses the petrol as a power source, will be replaced by electric powered vehicles. Heavy vehicle like truck, earth moving equipment, and trains which require high power, long range, and high torque. Normally, these vehicle uses diesel as the primary source of power. In future, these power source will be replaced by the hydrogen as source of power. 1 kilogram of hydrogen replaces around 4.5 liters of diesel fuel. Now, let us know about hydrogen vehicles. A hydrogen internal combustion engine vehicle, HICEV, is a type of hydrogen vehicle using an internal combustion engine. Hydrogen internal combustion engine vehicles are different from hydrogen fuel cell vehicles, which use electrochemical use of hydrogen rather than combustion. Instead, the hydrogen internal combustion engine is simply a modified version of the traditional gasoline-powered internal combustion engine. Hydrogen is clean burning. The only byproduct of hydrogen power is water and heat, both of which can be recycled. This essentially means turning an energy-consuming process into an energy-producing one. Toyota is cooking up new technology that has the potential not only to save the IC engines whose technology had been developed with time at an extreme, but also a big challenge to the EV vehicles. As waste of EV is also a challenge to decompose. High cost of replacement of battery system after a defined time in a vehicle is also a challenging one, and in long run high cost is involved. Toyota had done a tremendous job and invested more in hydrogen technology than EV vehicles. With patented technology and a strategic move to work with hydrogen technology, every combustion engine can use either petrol or diesel engine. So this new hydrogen technology will not only power cars but also truck, trains, ships, aircraft and other machinery that requires high power and torque. And it will decrease 18% of world carbon emissions generated by transportation. In the future, it will also ensure to generate its own powerhouse, which will power a manufacturing unit. The JCB engineering team has done a fantastic job to develop a brand new hydrogen engine. They have gone back to first principles to completely redesign the combustion process to work for hydrogen. JCB has also been at the forefront of electric technology development to meet customers' demands for zero-carbon products. The unique combustion properties of hydrogen enable the hydrogen engine to deliver the same power, the same torque, and the same efficiency that powers JCB machines today, but in a zero-carbon way. In present, the only downside is that hydrogen is difficult to handle. 1. Production facility are less and no to generate hydrogen. 2. Storage, it requires a costly system to store after generation. 3. Transportation also requires costly closed and pressurized container to transport. 4. Safety is also a concern as hydrogen is highly flammable. But petrol, LPG, CNG etc. are also highly inflatable and still in use with patented technology. This can be tackled with patented safety system as done by Toyota. The Toyota Mirai, for example, uses a patented design to prevent hydrogen leakage as well as shutting off the flow of hydrogen in the event of a collision and store the fuel tank outside of the cabin. In the unlikely event of a leak, the gas will vent harmlessly up into the atmosphere. Because hydrogen is lighter than air, it diffuses directly up into space at the rate of 20 miles per hour. Making it safe unless it is allowed to build up in enclosed spaces in large quantities. Toyota's strategy to invest more in hydrogen that other all companies were busy in electrical vehicle, a smart move by company to have a better solution which will not only save 100-year evolved technology but provide a better alternative to EV. As industry can't solo depend upon one technology. 1 kilogram of hydrogen replaces around 4.5 liters of diesel fuel. Now let's compare key factors of hydrogen and electric vehicle. Having seen the overall pros and cons for each type of vehicle, how do electric and hydrogen cars compare when examined on a number of key factors, such as range, charging, safety, emissions and cost? 1. Range. With electric cars, The range is highly dependent on which vehicle you buy and how many battery storage pack they have. Hydrogen fuel cell vehicles offer greater ranges and faster refueling times too. And only takes 5 minutes to fill up, as opposed to the hours it can take to recharge an electric vehicle. Here, winner is hydrogen vehicle. 2. Charging or refueling station availability. Hydrogen fuel is initial stage. It lack the production facility as fuel and supply chain, as it requires expensive transportation supply chain. While electric vehicles already have thousands of charging stations around across the globe and can be charged at home. Winner is electric. 3. Safety. Safety has been seen as a key concern for hydrogen fuel cells, which burns in air at concentrations ranging from 4 to 75%. However, technological advances have resolved many of these potential safety issues. Hydrogen is lighter than air. It diffuses directly up into space at the rate of 20 miles per hour, making it safe unless it is allowed to build up in enclosed spaces in large quantities. Electric batteries also come with their safety concerns and challenges. If lithium-ion batteries are allowed to overheat or overcharge, they can cause injury. Plus, should there be a fire, the batteries can ignite and are difficult to put out as the fuel for the fire is not vented away as with hydrogen. Vehicle manufacturers have been working to solve these issues by regulating temperatures and using multiple sets of smaller batteries to avoid overcharging. As with any fuel source, hydrogen and electric cars have their own comparable safety challenges. Winner is draw. 4. Emissions. While hydrogen and electric cars don't produce emissions from their exhausts, manufacturing lithium-ion batteries is an energy-intensive process, which, when added to charging-related emissions, equates to an average of 124 g of CO2 per kilometer for a 100 kilowatt-hour battery. Manufacture of hydrogen fuel cells isn't much better, with the Toyota Mirai fuel cell stacks equating to 120 g of CO2 per kilometer, although this can be greatly reduced when renewable energy is used to produce the hydrogen. Winner is draw. 5. Cost of ownership. Electric vehicles can be expensive to buy, depending on the exact model and manufacturer. On top of the cost of the vehicle, owners may also need to pay a monthly battery rental price. Hydrogen vehicles are more expensive than electric vehicles. With no budget options on the market currently, the price tag for a new hydrogen vehicle is comparative to that of a top-end electric vehicle. In addition, the cost of refueling is higher too, at around 50 to 75 pounds for a full tank. Winner is electric. Now, it seems that battery electric vehicles currently have the edge over hydrogen fuel cell vehicles. Hydrogen could help get the world to its climate goals faster. So hope that in near future green hydrogen will develop of affordable, more commercial applications, in order to drive towards the renewable energy transition and deliver reliable, cost-effective power that is sustainable for business, and sustainable for the earth. Thanks for watching. Please subscribe the channel and like the video. Thanks, and please share your views in comments section.